Hi, my name is Mr. Reddy from King Solomon Academy, and I'm going to do a short video on Pythagoras.
So here's what I'm going to show you in this video. First of all, what is Pythagoras' theorem? Second, how do you use Pythagoras' theorem? And third, how can you spot a question that can be solved using Pythagoras' theorem? So first of all, what is Pythagoras' theorem? Well, Pythagoras was a man who looked a bit like this. He was from ancient Greece, and he has his name attributed to this theorem that we called Pythagoras' theorem, which is the truth about how the side lengths of a right-angled triangle are related to each other. Here's a right-angled triangle, there's the right angle. The side opposite the right angle is called the hypotenuse. I'm going to call the other two sides A and B. So the theorem says that if you square the hypotenuse, it's equal to side A squared added to side B squared. It's actually very straightforward. H squared equals A squared plus B squared. Now this only works for right-angled triangles. So here's a few pictures of some other right-angled triangles. And it works for these. But it doesn't work for equilateral triangles, isosceles triangles, or scaling triangles. Oh no. Second, how do you use Pythagoras' theorem? So I'm going to do a couple of examples. Here's another right-angled triangle. There's the right angle. A, B, and hypotenuse. Right, let's change A and B for 4 centimetres and 9 centimetres. So H squared equals A squared plus B squared. So if I change A squared for 16 and B squared for 81, I find that H squared equals 97. And H is the square root of 97. So out comes the calculator, and I get 9.85 centimetres to 2 decimal places. Brilliant, that's the length of the hypotenuse. Thanks, Pythagoras. Here's another example. This time, I'm going to change the hypotenuse for 11 metres and side B for 9 metres. So I'll write out the formula again. And this time I've got 11 squared equals A squared plus 9 squared. So I've got to find A. 121 equals A squared plus 81. Subtract 81 from both sides. And I find that A squared is equal to 40, or 40 is equal to A squared. Therefore, A is equal to the square root of 40. Here comes the calculator bit. Bingo. 6.32 metres to 2 decimal places. Notice that I put the units and I've specified the degree of accuracy. Number 3. How can you spot a question that can be solved using Pythagoras' theorem? So I'm going to show you 4 different types of exam questions. First of all, straightforward questions. These are the type that I just showed you in the previous slide. There they are. Okay. A right-angled triangle inside a non-right-angled triangle. Here's an equilateral triangle. All 3 sides are the same. And the question says, find the area of this equilateral triangle. Now, I know that the formula for the area of a triangle is the vertical height times the base divided by 2. But I can't find the vertical height. But I can with Pythagoras. So it turns out the hypotenuse of my right-angled triangle is 6 centimetres, so I need to square that. And that's going to be equal to 3 centimetres squared plus b squared. So I do 36 equals 9 plus b squared. And with a bit of working out, I can find that b must be the square root of 27. And then I can go and use the square root of 27 to work out the area. Here's a third type of exam question. Prove that this triangle is a right-angled triangle. Well, it is a right-angled triangle if we can show that the hypotenuse squared is equal to a squared plus b squared. So I've got 13 squared equals 12 squared plus 5 squared. If this works out, if 169 is equal to 144 plus 25, which it is, then this triangle must be a right-angled triangle. Right, we're on to some new ones. Picture questions. GCSE exam questions love to throw in a picture with perhaps a hidden right-angled triangle in it, and it's your job to try and spot it. A favourite one seems to be a boat off the edge of a cliff, or a boat with a triangular sail. Spot the right angle. Oh, and there's a ladder against a brick wall. Lots of ladders get left outside brick walls, apparently. So my conclusion is that you need to be suspicious of any question that looks like it involves a right-angled triangle, because the chances are it's going to need Pythagoras to solve it.
I hope that's been useful. You can find more videos at mrreddy.com and youtube.com/KSA Mathematics.